In this lab, we will discuss C++ inheritance. We will learn what is inheritance, how does inheritance work, then we will discuss access control, and finally we will talk about function overriding. So what is inheritance? Inheritance is one of the most important concepts in object-oriented programming languages. One of the purposes of inheritance is to promote code reuse, because with inheritance, it is possible to define a class with some general characteristics, often referred to as the base or parent class, and then let other classes, called derived, inherited, or child classes, inherit these general characteristics from the base class. The derived class can then add more things that are unique to their own purposes. That's quite a mouthful, you are probably saying, but it's a common trait of human beings to make simple things seem complicated, right? Actually, this concept, like many other seemingly intimidating concepts, can be clearly explained with a simple example. So let's take a look. Here it is. Suppose we would like to manipulate points in a 2D space. It is natural for us to define a class for this purpose, and we could call it 2D. So here's the definition for this class. It has two member variables, x and y. Notice here how they are protected. This is a new form of access control that we will discuss in more detail later. For now, protected simply means that members can only be accessed by members of this base class and any derived classes. Then we have our public member data and functions. So here we only have member functions. And I want to introduce inline implementation, which is new syntax for you, I'm assuming. So here we have a 2D constructor. Notice here it's a constructor since it has the same name as its class. It takes two parameters, I and j. And then we have a colon here. And we have a function call that says x, and we pass it I. And then we have another function call y, and we pass it j. If you had to guess what's happening here, you would probably notice how x has the same name as your member variable, and y has the same name as your member variable. So these two function calls here are initializing those values. X is set to the value of I, and y is set to the value of j. So here we have an initialization list in the constructor. Then inside of the curly braces here, we could add in any extra code that this function would need. I would recommend only writing up to 5 lines of code inside of the curly braces here, because when you have this function call, the compiler will replace it with your inline implementation. It's also difficult to read that much code in that small spot as well. Now we have the inline implementation of some member functions. This will help clear up how the syntax works a bit more. So I have my setX function. It takes a parameter called newX, and inside of the curly braces here, I have the inline implementation of this function. All it does is set x equal to new x, and that's it. Same thing with set y, it sets y equal to the parameter coming in called new y. Then for get x, I simply return the value of x, and for get y, I return the value of y. So this will save you time writing code, and it looks a lot more neat and clean using inline implementation. So that was our base class. Suppose later on we decide to implement a class to deal with points in a 3D place. An intuitive way of implementing this 3D class would be to just copy and paste what we had in 2D and then add in what we need for the third coordinate. So just to be clear, this is the definition of the 3D class without using inheritance. So what we would do up to this point, based on what we know, is we would add the third coordinate z in order to have a 3D point. So everything in red here shows the differences between the definition of the 2D class and our 3D class here. 3D has an additional member variable z and two additional member functions, set z and get z. In other words, the definition of the 3D class adds a little new code to the definition of the 2D class.